Kwang Central Prison, the biological toll of living in the big tiger. What happens to the human brain and body when it is pushed past the point of total exhaustion? Not the exhaustion you feel after a long week. Not the kind that sleep repairs. The kind that accumulates silently over years, inside walls where the air never moves, where the temperature never drops, where the human body is slowly, methodically, physiologically dismantled. In the shadows of what prisoners call the Big Tiger, Kwang Central Prison, located just north of Bangkok, Thailand, a unique cocktail of malnutrition, tropical disease, and chronic environmental stress has been doing something that most prison systems would never officially acknowledge. It is rewriting human biology. Today, we are not going to tell a story. We are going to conduct an investigation. A forensic, clinical examination of what extreme environmental stress does to the human body at the cellular level, and why Kwang may be the most biologically hostile correctional environment in the documented world. The question before us is precise. Is it physiologically possible to endure the conditions inside Kwang without suffering permanent, irreversible biological damage? The evidence, as we will examine it, suggests the answer is no. Kwang Central Prison was constructed in 1931 on the west bank of the Chao Phraya River. It was designed for approximately 3,500 inmates. Today, it holds in excess of 7,000. Its population is drawn from the full spectrum of Thailand's criminal code, with a significant percentage serving sentences under Thailand's mandatory minimum drug trafficking laws that carry, in some cases, the death penalty. International human rights observers have documented the facility for decades. What they have found is not merely poor living conditions. What they have found is a biological environment that operates like a closed system of accelerated physiological destruction. Now let us examine this system, component by component, the way a forensic scientist examines evidence, not with emotion, but with precision. The kiln, thermal stress, and the permanent state of hyperthermia. The first biological assault begins the moment the body enters the environment. Thailand's central plains average between 35 and 40 degrees Celsius during the hottest months. Inside Kwang, in cells where concrete walls absorb and radiate heat, where ventilation is minimal, where the density of human bodies adds additional thermal load, internal temperatures routinely exceed ambient outdoor readings. The human body maintains a core temperature of approximately 37 degrees Celsius. It will expend extraordinary metabolic resources to protect that number. When the environmental temperature approaches or exceeds core body temperature, the body's thermoregulatory system does not simply become uncomfortable. It enters a state of physiological crisis. Here is what this means in cellular terms. The body begins diverting blood flow toward the skin surface, away from internal organs, in an attempt to radiate heat. The heart rate elevates. Cardiac workload increases. Cortisol, the primary stress hormone, floods the bloodstream. And this is not a periodic event. In Kwang, for inmates who cannot access shade, who cannot control their environment, whose bodies have no recovery period from the thermal load, this is a permanent state. The metabolic cost of chronically fighting to cool down is enormous. It accelerates caloric depletion in a population that is already nutritionally compromised. It places sustained pressure on the kidneys, which must filter an increasingly concentrated bloodstream as the body loses water through perspiration it cannot adequately replace. And it begins, quietly, invisibly, the process of cellular degradation. Heat stress at the cellular level generates reactive oxygen species, what biochemists call free radicals. These are unstable molecular fragments that attack cell membranes, damage mitochondrial DNA, and accelerate what is known as oxidative stress. Oxidative stress, over time, is one of the primary biological drivers of accelerated aging. Pause and consider this. The body is not simply uncomfortable in extreme heat. It is actively consuming itself to stay alive. Have you ever worked in extreme heat for a full day and felt completely depleted afterward? Unable to think clearly, physically drained in a way that sleep barely addressed? Now imagine that day becoming every day, indefinitely, with no recovery period and no access to adequate food or clean water. That is where we begin. The crowding crisis, pathogen exchange and the microbiome of misery. The second biological assault is social, which is to say, it comes from the bodies of others. The United Nations Standard Minimum Rules for the Treatment of Prisoners specify that each prisoner should have adequate living space. The threshold most health organizations recognize for safe occupancy in a confined space is a minimum of 5.4 square meters per person. In the overcrowded wings of Bang Kwang, credible reports document effective sleeping space as low as 1 square meter per inmate. What this creates, from a microbiological standpoint, is not simply discomfort. It creates what we might call a microbiome of misery, a closed, high-density biological ecosystem where pathogenic bacteria, respiratory viruses, fungal infections, and skin parasites cycle between hosts with extraordinary efficiency. Consider the respiratory pathway alone. A single inmate with active pulmonary tuberculosis, in a poorly ventilated space, can expose every individual within a several-meter radius. In a cell holding 20 men in a space designed for 4, every respiratory event, every cough, every exhaled breath, becomes a vector transmission opportunity. Bang Kwang has historically reported tuberculosis rates significantly exceeding general Thai population statistics. That is not a coincidence. That is a mathematical consequence of the environment. But the pathogen exchange does not stop with respiratory disease. Skin-to-skin proximity, shared surfaces, inadequate sanitation infrastructure, these create simultaneous vectors for fungal infections, scabies, impetigo, and in the context of compromised immune systems, infections that healthy individuals would clear with minimal symptoms become chronic, systemic threats. Now layer on top of this the chronic cortisol elevation we identified in Pillar 1. Cortisol, in sustained elevated concentrations, is directly immunosuppressive. It reduces the proliferation of lymphocytes, the white blood cells that constitute the adaptive immune response. It suppresses the function of natural killer cells. It shifts immune activity away from the kind of cellular immunity that fights intracellular pathogens, including viruses and mycobacteria like tuberculosis, and toward a pattern that leaves these threats largely unchallenged. The thermal stress breaks the body down. The overcrowding floods the environment with pathogens. The cortisol response from the cumulative stress of confinement disables the immune system's ability to respond. These three factors do not add together. They multiply. And then there is sleep. In conditions of extreme heat, noise, overcrowding, and psychological hypervigilance, a state well documented in carceral environments where threat detection remains continuously activated, deep restorative sleep is physiologically impaired. The immune system conducts the majority of its repair and regulatory functions during deep sleep phases. Chronic sleep disruption compounds every immunological deficit we have identified. Pause and consider, we are not describing suffering. We are describing a biological sequence. The environment does not intend to destroy the immune system. It simply creates every necessary condition for that destruction to occur automatically. When was the last time you felt truly rested? Now consider what your immune system would look like after 5 years of half sleep in a room where the temperature never drops below 35 degrees Celsius and the person next to you is coughing through the night. The nutritional void, the modern return of deficiency disease. The third biological assault is the most ancient and perhaps the most insidious because its effects are slow, cumulative, and by the time they are visible, they have already been occurring at the cellular level for months or years. The standard prison diet at Bang Kwang has been documented by multiple observers as heavily weighted towards simple carbohydrates, rice, predominantly, with limited protein, minimal fresh produce, and negligible micronutrient density. This is not merely poor nutrition. This is the nutritional profile that, historically, produced the great deficiency diseases that decimated populations before the era of modern food science. Let us examine 3 specific nutritional failures and their precise biological consequences. The first, vitamin C deficiency and the return of scurvy. Vitamin C, ascorbic acid, is not optional. It is essential to the synthesis of collagen, the structural protein that maintains the integrity of blood vessel walls, skin, gums, and connective tissue throughout the body. In the absence of adequate vitamin C, collagen synthesis fails. Blood vessels begin to lose structural integrity. Gums recede and bleed. Old wounds, wounds that healed months or years ago, begin to reopen as the collagen matrix that closed them deteriorates. Fatigue becomes profound. Joints ache. The immune function collapses further. This is scurvy, a disease historically associated with 18th century sailors. A disease that has returned, in precisely these environments, wherever a prison population is denied consistent access to fresh fruit and vegetables. Symptoms emerge within 4 to 6 weeks of near-zero vitamin C intake. Full scurvy develops within 3 months. In an environment where fresh produce is consistently absent, this timeline is not theoretical. The second, thiamine deficiency and neurological failure. Thiamine, vitamin B1, is required for glucose metabolism. The brain and nervous system, which run almost exclusively on glucose, are catastrophically dependent on thiamine for energy production. A diet of polished white rice, which removes the thiamine-containing outer bran layer, combined with minimal thiamine from other sources, produces a condition called beriberi. Wet beriberi attacks the cardiovascular system. The heart enlarges as it attempts to compensate for circulatory failure. Fluid accumulates in the extremities and eventually in the lungs. In its most acute form, it is fatal. Dry beriberi attacks the peripheral nervous system. Patients describe burning sensations in the feet and hands, progressive weakness, and in advanced stages, a neurological emergency called Wernicke's encephalopathy, characterized by mental confusion, loss of coordination, and if left untreated, permanent brain damage. That permanent neurological condition is called Korsakoff syndrome. It destroys the ability to form new memories. The damage is irreversible, not improved with treatment, not recovered with release. Irreversible. The third, the skeletal consequences. Long-term protein deficiency prevents the maintenance and repair of muscle tissue. The body, in a state of caloric and protein deficit while simultaneously under the metabolic load of thermoregulatory stress and chronic immune activation, will begin catabolizing its own muscle mass for fuel. It will consume itself. Calcium and vitamin D deficiency leads to the progressive demineralization of bone. Bones thin. Structural integrity decreases. The risk of fracture from minor trauma increases significantly. In inmates who have been held for 5 years or more, this process has progressed far enough to be visible. In the posture, in the gait, in the prominence of the skeletal structure beneath skin that has thinned and lost its subcutaneous fat layer. Pause and consider. The body is not being punished by external force. It is consuming itself from within, because the external environment has removed the resources it needs to maintain its own structure. Have you ever noticed how a single missed meal affects your ability to concentrate? Now consider what 3 years of nutritional deficit does to the architecture of the nervous system. The forensic analysis, accelerated aging and telomere erosion. We have now identified 3 major biological assault vectors: thermal stress, pathogen exposure with immune suppression, and nutritional deficit. Now we examine what happens when all 3 operate simultaneously over years, and what that means for biological age. At the tip of each chromosome in every cell in the human body sits a protective cap called a telomere. These caps shorten slightly with every cell division. When they become too short, the cell can no longer divide. It enters a state called senescence, or it dies. The rate of telomere shortening is widely used by researchers as a biological clock, a measure of how quickly a body is aging at the cellular level. Oxidative stress accelerates telomere shortening. Chronic cortisol elevation accelerates telomere shortening. Chronic infection and immune activation accelerate telomere shortening. Malnutrition, specifically deficiencies in antioxidants and essential micronutrients, accelerates telomere shortening. Bang Kwang delivers all 4 of these telomere-eroding stressors simultaneously, without respite, for years or decades. Research consistently demonstrates that adverse social environments, chronic psychological stress, and nutritional deprivation are associated with telomere lengths equivalent to 10 to 20 additional years of biological aging when compared to chronological age. The body ages faster than the calendar. What this means in practice is what observers have documented and what prisoners themselves describe, something they call prisoner's face. The skin loses its elasticity. Oxidative damage from sustained free radical activity destroys the collagen and elastin networks in the dermis. Complexion darkens and becomes uneven. Fine lines deepen rapidly. The face of a 35-year-old inmate who has served 10 years may display the dermal markers of a 55-year-old. And this is not cosmetic. It is a visible surface indicator of a process that is occurring identically in every organ of the body. The liver, the kidneys, the cardiovascular system, the brain. A forensic gerontologist examining systemic biomarkers, telomere length, inflammatory cytokine levels, oxidative stress markers, organ function indicators, would assign a biological age to a long-term Bang Kwang inmate that diverges dramatically from their chronological age. Pause and consider, we do not age uniformly. We age according to what our environments demand of ourselves. Bang Kwang demands everything. The point of biological surrender. Every biological system has a compensation threshold, a point up to which it can adapt, adjust, and maintain function despite adverse conditions. Beyond that threshold, compensation fails. The cardiovascular system compensates for heat stress by elevating heart rate and redistributing blood flow. Over years, this sustained elevated cardiac workload produces structural changes in the heart muscle, hypertrophy, stiffening, that increase the risk of arrhythmia and cardiac failure. The kidneys compensate for dehydration by concentrating urine. Over years of chronic mild dehydration in a hot environment with limited fluid intake, the sustained concentration of filtrate damages the tubular cells of the kidney, producing a form of chronic kidney disease with no single dramatic event, just progressive, quiet deterioration. The immune system compensates for pathogen load through chronic low-grade activation. Over years, this sustained inflammatory state, what immunologists call inflammaging, becomes itself a source of organ damage. Chronic inflammation is a primary driver of cardiovascular disease, neurological deterioration, and systemic tissue damage associated with premature death. The nervous system compensates for nutritional deficit by prioritizing essential functions and reducing output to secondary ones: cognition, memory, executive function. Over years, in the context of thiamine and other B vitamin deficits, the neurons themselves begin to die. The point of biological surrender is not a dramatic event. There is no single moment of collapse. It is a threshold reached gradually where the cumulative damage across multiple organ systems has exceeded the body's capacity for self-repair. And once crossed, it is not reversible. This is perhaps the most significant finding of this investigation. What Bang Kwang does to the body does not end when a prisoner is released. A man who serves 15 years inside the Big Tiger and walks out the gates carries his incarceration with him. In his telomeres, in his cardiac muscle, in his kidney function, in his nervous system, in the accelerated biological aging that will shorten his life and reduce its quality for every year he has remaining. The punishment does not end at the gate. The descent, psychological severance from the living. For those on death row in Bang Kwang, the biological story eventually gives way to a psychological one. And in some respects, the psychological literature is even more disturbing than the physiological. The condemned in Bang Kwang are notified of their execution date with minimal advance notice. The specific protocol is designed, whether intentionally or incidentally, to prevent the kind of extended psychological processing that might allow acceptance. What the 48 hours before execution produces in the human brain is not simply fear. It is a state of profound neurological disruption that researchers who study death anxiety describe as psychological severance, a cognitive process in which the brain attempts to complete a task it has no evolutionary template for completing, the conceptualization of its own non-existence. The brain cannot model its own absence. It can model loss of others. It can model sleep. It cannot model the permanent cessation of the self that experiences. So it does not process this information as information. It processes it as threat, and the threat response it generates is catastrophic and unresolvable. The amygdala, the threat detection center, fires continuously. Cortisol and adrenaline flood the system. The prefrontal cortex, the seat of rational thought and executive control, is effectively bypassed. The individual becomes physiologically incapable of the calm, measured processing of their situation that they might consciously wish to achieve. What this produces, from the accounts of chaplains, prison officers, and death row inmates who have had their sentences commuted at the last moment, is a state of total sensory hypervigilance combined with a progressive narrowing of consciousness, as if the perceptual field itself is contracting toward a single, unbearable point. The walk to the execution chamber is not a physical journey. It is the final negotiation between the conscious mind and the reality it cannot accept. Every sense sharpens. Sound becomes overwhelming. Light seems too bright. Time distorts, stretching and compressing in ways that have no ordinary parallel. The room itself is clinical, designed to be so. The state requires the appearance of order, of procedure, of an official process conducted within established parameters. The witnesses, officials, observers, perhaps a chaplain, occupy a space defined by their silence. They are there to confirm that a process is completed. Their presence is institutional, not personal. And this institutional silence, for the condemned, is its own particular horror. Because the deepest human terror is not pain. It is erasure without witness. The terror that one's existence will end and no one who truly matters will be there, truly present, to see it. The psychological siege of the final 48 hours does not end with the individual. Its effects ripple outward. Officers who participate in executions over extended periods develop measurable psychological symptoms consistent with secondary traumatic stress, the trauma of proximity to another's death, repeated over time, without adequate psychological support or processing. Inmates who observe the preparation and aftermath of executions within the prison community demonstrate measurable increases in hypervigilance, anxiety, and behavioral dysregulation for weeks following each event. And the broader question, the one this investigation ultimately forces us to sit with, is what it reveals about the limits of what any society should be willing to demand of the human body and mind in the name of justice. We have conducted this investigation as scientists would, following the evidence where it leads, not where we might prefer it to go. What the evidence shows us is this: the human body is extraordinarily resilient. It is built to adapt, compensate, and endure across a remarkable range of adverse conditions. But resilience has limits. And those limits are not arbitrary. They are biological facts, encoded in the chemistry of the cell, the architecture of the organ, the structure of the molecule. Bang Kwang does not simply confine. It operates as what we might most accurately call a biological furnace, an environment that systematically exceeds the human body's adaptive limits across multiple simultaneous axes, over periods measured in years and decades. The red flags that this investigation teaches us to recognize are not only the dramatic ones, the visible suffering, the disease outbreaks, the mortality statistics. They are the quiet ones. The face that looks 10 years older than it should. The man who struggles to remember what he was saying. The woman who cannot walk without pain from the neuropathy that settled into her feet in the second year of incarceration. The heart that beats irregularly in a man of 38. These are the biological record of what happened inside the walls of the Big Tiger. A record written not in official documents, but in the cells of the body, in the telomeres, in the organ function, in the accelerated deterioration of systems that were never designed to face what they faced. The lesson is not simply about one prison in Thailand. The lesson is about what happens when any closed system, any institution, any environment, systematically removes from a human being the resources that biology requires for survival and calls the result something other than what it is. The body does not lie. Long after the mind has adapted, after the spirit has found whatever equilibrium it can, after the years have passed and the walls have become the only reality a person has known, the cells remember. Every deprivation, every thermal assault, every pathogen, every night of inadequate sleep, every meal that provided calories but not nutrition, the cells remember. And they keep the record.